Good morning, guys. Today, uh, today we will try to understand design patterns. But before going to this, since there are different types of design pattern like factory pattern, abstract factory, singleton, behavioral, and lots. There are many more. But before going into these patterns that generally asked in the interviews, we have to think. Our thinking should be in the design way, in the object-oriented world. Like uh, we all are using design pattern in our day-to-day programming life. Suppose I hope you guys totally aware of ops concept. Then only you can watch this video. Class 1 obj is equal to new class 1. So this is also a design pattern. Now before jumping into the design thinking way, we will go through the step by step and try to figure out what should be our solution for different types of problems, how we face the problem, what should be our approach in the object oriented world. So let's start. Suppose you are as a programmer P1 work into some organization O1 which makes a video game. Okay, and now programmers comes to you and say, hey P1, we are going to create a video game that is a fighter plane. Okay, so now I start thinking about this fighter plane video game. Now what we will do, you as a programmer P1 will think that we will have a base class, and as per the requirement, suppose there is an engine start mechanism and display method. And for hypothetically, let's consider this engine start method is uh, common in all, and display will be different for the different uh, fighter plane. Let's think more. Suppose we are going to display Sukhoi, Tejas, MiG, and Rafale. So suppose Sukhoi looks like this, Tejas looks like this, MiG look like this, and Rafale. These are the hypothetically. So these are the four types of look and feel for this fighter plane. So what we'll do, we'll in the display class we will make display as abstract. I hope you guys are aware of this abstract keyword. We'll make this abstract display as abstract so that all the derived class, these are the derived class, all the derived class, because these are the concrete. So all the derived class will have their own display method and will show on the video game. Now let's jump into the code. So here is our abstract class, that is a fighter plane which have then abstract method, display method, and engine start as described in the board. And this is the Sukhoi fighter plane, which derived from the our base abstract class fighter plane, which have their own display method. Same Rafale. Okay, great. Now we are going to use this. Why so? Why so? Why? Sukhoi fighter plane. Yeah, great, great. Oh, hold for a minute. Let me comment all this code. Here we have same base class. Let me comment all this code. We will go one by one. Okay, now we'll run this code. Let me show you output. Sukhoi display, then engine start, Rafale display, Rafale start. Now you go. Now as a programmer, you have developed as per the requirement. Now, while development, you come to know that project manager comes to you. Hey, I forgot to mention about the flying behavior of all fighter plane. In the scope. So what we'll do? Don't worry, sir. We will add this flying in the base class. And all the inheriting class will have this flying behavior automatically. Great. Now let's jump into the code. Let me put this flying. Let me open this. Now this fighter plane have display abstract and have flying behavior. Okay. Now we'll open this code. Okay, and we'll run. Now let me show you the code. Sukhoi view and engine start, then Sukhoi fly. Same Rafale view, Rafale start, and Rafale fly. Great. Till now it's good to go. Now you give this your DLL, your solutions. Now you give your solutions to PM. Now PM goes to client. Now in the client meeting, client see the video game and say, hey PM, we want to display wooden fighter plane in the video game. As I told you earlier, this is totally a hypothetical example. So this is a wooden fighter plane. Okay. Now what will happen? According to your approach, if wooden fighter plane will inherit from the base class, then we'll have fly method. But wooden fighter plane cannot fly. Let's see with example. This is the wooden fighter plane class. Okay, now Sukhoi can fly, Rafale can fly, but if you can see, Odin can also fly. So we are giving Odin class to fly, which is a wrong approach. So now what? Now what? Let's jump into the our design thinking approach. Sorry, some pain is working not properly. So our approach, second approach. So what we will do? Okay, the programmer will think that, oh, so in the base class we have applied fly method. Let me show you code. In the base class, we have written fly method so that all inheriting class can have this flying behavior. So let me take it out from the base class. Let it take it out from the base class and make a iFlyable interface. And this interface, all the derived class which can fly will implement this iFlyable behavior. So let's try with the code. Now let me put this fighter plane comment, put this flying behavior comment from the base class, and let's move into the iFlyable behavior, iFlyable interface. Let me put a comment to this code. Okay, now here we can see Sukhoi fighter plane is deriving from the fighter plane base class and iFlyable interface, implementing iFlyable interface. Here Sukhoi class they have on flying method, Rafale have their own flying method, and since Odin cannot fly, we are not implementing iFlyable in the Odin fighter plane. Great. Now here we are not getting fly method. Great. Let me put this one also comment. Our code will run. Great. But here is another problem. What is the problem? Suppose let's think. Suppose there are 50 derived class from this base class and all can fly, and client want to change flying behavior. I will explain you for flying behavior. So what we'll do, in all 50 classes, you have to change the flying method as per behavior, which is very hectic job, and it will not a very good solution to the client, because every time if client want to change more flying behavior, then we'll have to change into derived class. Suppose if project is very big and have a 100 derived class, then it will uh, it will very tough task for a programmer to maintain also. So uh, let's think about the flying behavior. Suppose there are three flying behavior as per client needs. So what is the three flying behavior? One is supersonic. Fighter plane can fly with the supersonic speed. One, run before fly, that is on the runway, and fly without run, like on the naval ship. Okay, these are the three flying behavior that uh, we have to introduce in the flying method, so that uh, a fighter plane can fly. So now our approach will change here. Now if you can see flying behavior like supersonic, all these flying behavior, 1 2 3, all these flying behavior are concrete in nature. Why I'm saying that concrete in nature? Because they have their object. Concrete in nature means they will have their object. I will explain you. So these are the concrete in natures. So what we'll do, we'll create a flyable behavior interface which have fly method as before, and we have supersonic class which will implement iFlyable. Same, run before fly which have iFlyable behavior, and fly with run which have iFlyable behavior. These are the three classes which will have their concrete uh, object, which have their concrete uh, classes. They have their own object. So if suppose client want to change the supersonic behavior, or there is some changes comes in the supersonic behavior, then we will have to change only in the supersonic class. If there is any changes in the run before fly, then we will have to change it here only. And if so, we don't need to change each and every derived class. We have to change in the behavior. Now I hope you guys are are understanding our approach. Great. Now let's move into the code. Now here is an interface, iFlyable behavior, and here is the class. There's a supersonic speed, is the run before fly, and run without fly. These are the three behavioral classes. Great. Which can fly, which have their on fly method. Now this is the abstract class. This is the base class, same as before, but there is some changes, minor changes. It will have the reference of iFlyable behavior interface, abstract display as a scene, okay, and have the perform fly method, which will call the fly method and engine start as before. Now let me put one uncomment. Let me uncomment this code. So this is a Tejas fighter plane, which are actually run before fly. So it will inherit from the fighter plane, the base class, and in the constructor we are initializing with the run before fly, because we are creating the Tejas fighter plane which can run before fly. So we are initializing its behavior, okay, and displaying here. Now let's move to the main method. Let me put all this code comment, and only this part I will. Okay, so here we are initializing run before class and trying to fly. Okay, now let's move to the code and this code. Oh, let me put there is another fighter plane class which we fighter plane fighter, where is, yeah. Now we are initializing Tejas run before class and displaying that and then performing. Let's check with the debugging. Move into the constructor, then it will move into the base class. Now in the derived class Tejas before run, it will initialize flying behavior. Okay, now move into this, it will go and call to the Tejas view. Engine start, now perform fly. Now here it will call perform fly, which is I behavior, and in the I behavior we are getting, if you check here, it is run before fly. It's checking with the run before fly. Now so run before fly. I hope you guys are able to understand our approach. Now let's check with the another example. Okay. Sorry. Which class we have? Make supersonic. Great. Now after the code. Main class. Here will fighter plane make supersonic. Continue. Make supersonic will have the on display MS will have their engine start and ms.perform fly. Let me run this code. Now same. Now flying behavior initialize with the supersonic speed. Great. Now perform fly. It's called the perform fly, and when we in the perform fly, when we call the fly method, it will go to supersonic speed. Now if you check that, it's a flying with the supersonic speed. Which one? So make can fly with a supersonic speed. There is no need to change in the code every time if there is any change in the behavior. So hope you understand our design thinking approach in the object oriented world. Thank you guys.